Uh, Thank you, Alex. So good afternoon, everyone. Like was said, my name is Kofi. This talk's called Guaranteed Refactors. And all the slides are online already if you prefer to look on your phone or laptop. They're on my website, kofi.sexy, and you can find the link right at the top of the page. So as was also already mentioned, the benefit of going second to last is that I can actually kind of gloss through a lot of my slides. I didn't realize my coworker Michael would be up here talking about HubTran today, but we do have open roles at engineering.hubtran.com, and we have 60% of our front end in Elm. That's a slow migration we're taking on, but I do have the opportunity to work primarily in Elm, which is a lot of fun. I was also mentioned is that I help organize the Chicago Elm meetup. So for any folks, if Chicago is home or a neighboring town, then we'd love to see you. It's once a month. It's a pretty chill event. So the easiest way is probably just to Google Chicago Elm Meetup or look on meetup.com. Thank you, audience, for having me up here, for looking at me and my slides while I talk. Thanks to the organizers for putting on this conference. And special thanks to everyone who's traveling. I'm glad that you got to experience a sunny, mildly warm Chicago. And as I was thinking through my talk, I became inspired by this logo. I think it's beautiful. I think Colleen is the one to thank for that, so thank you. Carolyn, dang it. Thank you. I decided to use the logo to communicate the outline of where we're going. So the bulk of this talk is around this tool that I have been playing with called Elm Snapshot. I've been implementing it and thinking about it for a while. It's the root of this talk, but we'll be building upon it for the majority of the talk and just reflections about Elm and programming and refactoring. And so refactorability is the second main kind of thing I had in mind when creating this talk. What is it? How do we get more of it? It's great. A separate reflection is about building tools with types. That's leveraging the Elm compiler while we're building tools for the language. And I'm not the first person to write code that interacts with Elm's type system, but I wanted to share a bit about how I did it concretely. And maybe you'll feel inspired or equipped to build your own tools with types. And finally, at the end, I'll zoom out to answer the question, when will I actually use this in real life? And we'll talk a bit about learning in general. And so that's just a little bit of structure for folks who like to keep structure in their head while I'm going. I'm not really going to come back to these slides concretely, but if you don't like structure, then it's safe for you to start listening now. So my story with this project starts when I came across this function in the HubTran code base. It's an Elm function that someone wrote. And it's based on a similar function in Rails, if you're familiar with that. And the first argument to this function takes 3 arguments. The first is a string. And in the demo example, I'm going to pass the string nobody into this function. The second string is a conjunction word, usually. And so we'll pass an and. And the third argument is a list of strings. And for the first test, we will pass an empty list. So toSentence, when you call it, will return a string. And in the scenario when you have passed an empty list, it'll just return the first string that you passed it, which we call the empty string or the default string. If you pass exactly one member in the list, toSentence should return just that. And then if you pass 2, it'll use the conjunction to join the 2 members. If you pass more than 2, it uses the Oxford comma style to combine all of the elements. Okay, so these are the 4 cases, the 4 scenarios I just ran through. I just collapsed them all into one page. And when I came across this function, I opened the REPL and tested these scenarios because we didn't have any unit tests for this function. And I couldn't 100% decipher that it was doing this when I read the function. And I think that was because the original implementation had a bunch of branches. In my mind, there's kind of 4 logical branches. It's the branches I just showed you. But the implementation had 1 bunch of branches. And I couldn't figure out exactly why. So I decided to take a stab at simplifying the function for the next person who came along. And the goal is to make 1 bunch of branches into just 4 branches. So I went into my layer, and I coded. Code. 3 codes later, I had a function. And I re-imported it into the REPL, tested these same scenarios, and they all worked, so I was pleased. However, I was a little bit worried because I had this nagging question: how could I be more confident? All I did in the scenario that I just showed you was I imposed my understanding of what the function should do, validated that yes, the function did at least what I thought it should do, and then I just wrote a function that did only what I thought it should do. So there is a realistic possibility that the previous author thought of edge cases that I hadn't thought of yet, and since I hadn't thought of them, I didn't write any tests for them, and I didn't run them in the REPL. So that's kind of an issue with unit tests in general, is that we write tests for what we think to write tests for. And so in Elm, we have another option that's baked into the standard testing tool, and I'm talking about Fuzz Tests. And so if you've never heard of Fuzz, actually, scrap that, everyone's heard of Fuzz Tests now. Next slide. So here's how I write a Fuzz test in Elm, which is that I actually just copy and paste the annotation of the function that I'm about to test into the test file. And I go through line by line. I change the first line to fuzz with the number of arguments that this function takes. And then for each type, if it's a primitive type or a standard library type, then you can find the corresponding fuzzer in the fuzz module. And so you pass in the arguments like you would maybe in a JSON decoder setting. And finally, you have the body of the fuzz test, which is where you put your description and the expectation. And A, B, and C are going to be random inputs generated for this fuzz test and run a bunch of times. And filling in the body of this function is actually the tricky part, in my view, of creating fuzz tests and creating good fuzz tests. Because if you don't know what A, B, and C are, then how do you know what to write there? So it's actually, I think, a skill you can learn, and it takes practice. But luckily, we don't need any of that right now, because all I want to do is make sure that the function that I just wrote works the same as the function that was there before. So what I'm going to do is implement my function as toSentence2, and then call toSentence originally with A, B, and C, and make sure that for every time I call it, the outputs are exactly the same. So that process, in summary, is that we started with a type annotation, and we just mechanically created a fuzz test by going line by line through the annotation. And we didn't actually know anything about how toSentence worked. In fact, I haven't showed you the body of how toSentence worked at all. I've only showed you type annotations. And so since we were able to do that process with a few rules, that might be a good opportunity. It might signal to us that there could be some tooling to make that experience a little bit nicer, because it was a fairly mechanical process, and we can encode those rules into code. So I built a prototype of a tool that would work like that, and this is how it works. This is a demo. This is how I like to do demos. I just take screenshots of my terminal. No risk. It's great. So this is my editor. On the left is my terminal, and on the right is the Elm module, toSentence.elm. So the original actual implementation is in toSentence.v1. So I'm just using this function to proxy into v1 right now, and then my new implementation is in v2. And so the tool I've been calling Elm Snapshot is a command line program that takes one argument, and that argument is the file for which you want to create a snapshot for. When you run it, it will report that it generated a snapshot and provide you with a unique number. And under the hood, it just generates a regular Elm test module for you with a bunch of custom fuzz tests for your code based on the signature to the exposed functions. And since it's an Elm test module, you can run Elm test on it. And I'm going to use the watch flag, so it'll pick up changes, which is just a normal thing that Elm test does. I haven't done anything to Elm test to make this work. And so, of course, the test should all pass, because I actually haven't changed the module that we're looking at on the right. And they do in my screenshot. If I change it to something obviously wrong, then Elm test will rebuild my project like it normally does, and all of my tests will fail. Since the snapshot is a regular test module, you get the expectation, and you see that it's comparing obviously wrong to a bunch of tricky strings, which is what fuzzers are all about, generating values to break your code. So I'm going to go ahead and switch my source file to use the version of toSentence from toSentence v2, and Elm test rebuilds my project, And my tests pass, which is great. It gives me a lot more confidence that I didn't break anything at HubTran. So once I got this idea in my head for Elm Snapshot, I started seeing the idea everywhere. And my favorite place that I saw this was on Ted Kaminsky's blog. I highly recommend everyone to check it out. It's at tedinsky.com. And they call the idea ephemeral model-based testing, which is wordy. But I think it hits the main ideas. And the ephemeral part is the part that I think is a little unique, and I hadn't seen that discussed very many other places. Because with our two-sentence refactor, once we've made the changes that we want and the tests are passing, we can actually delete the tests, because if we ever needed those tests again, they're very easy to generate with a tool like Elm Snapshot. So Ted talks about how programmers can be maybe averse to this idea of keeping around code just so that we can reference it in our tests, especially if it's code in our source directories. And so that's where tooling like Elm Snapshot can make it a little easier or more palatable, because it kind of hides some of that away from you. And it makes it pretty easy to clean up after the fact whenever you're done with those tests. So that's the basic idea and the proposed benefit. So when would something like this be useful? There are a couple of conditions that I've kind of distilled, and they're both true in the story that I just shared about two-sentence. The first is that tests are either non-existent or underspecified. That means that even if you see a passing test suite, you're not confident that it has captured everything you're interested in capturing about the behavior of that code. And then you have to have a chance to refactor or rewrite parts. And refactor, rewrite, what I mean there is that you are setting out not to change the behavior of the code under tests. And so you might want to do this for a lot of reasons. You might want to change a data structure to maybe have different performance characteristics under the hood, even though you want to keep the external type signatures the same. You might want to update an entire dependency, actually. And if you've wrapped a dependency in such a way that the types on the outside of your module are going to be the same, then a tool like Elm Snapshot might be helpful. You might even be doing some sort of kata, and maybe they give you a bunch of messy code with nested if statements, and it might be a good opportunity to generate some tests, because you know that the code that you're going to be working with works in a particular way, and all you want to do is preserve that behavior. So in a previous life, under these conditions, my response would have been, Kofi, you should have written more tests, or Kofi, you should stop right now what you're doing and write tests. But I think that that response that I had to myself is missing a big advantage that current me has, and current me has a working implementation. I have a working code base that works at least in my mind how I want it to work. And whether or not there are lurking bugs is an open question, but I'm content to maintain the behavior for now. So as long as I'm comparing a future system to my current system, then I'm always going to have one of these three outcomes when I'm using a tool like Elm Snapshot. So outcome number one is that your tests pass, which means both systems are exactly the same. And this is great. That means you perfectly did a refactor. Outcome number two is that your old system has a bug, which is better. This is awesome. You discovered a bug while you were trying to keep your system the exact same, and you wouldn't have even known that you discovered and fixed that bug if you hadn't have tried to change your system to keep it the exact same. It's great. The last is not as good, but at least you know. You have a failing test, and you fix it, and then eventually you'll have one of the other two, hopefully. So there you have it. That's how you get a guaranteed refactor. Here's something you've probably heard today. I say this all the time. I imagine other people have said it up here. Elm is easy to refactor. I know I've said it in conversation on the floor earlier today. And I think it captures a common sentiment and experience that a lot of us have coming to Elm, especially when we've come from languages in which we are scared to make certain types of changes. At HubTran, I work on a project where someone misspelled the word failure, which is such an ironic word to misspell. And they forgot the R. They forgot the R, so it reads fail you. And and we still have it. We never changed it because it's in a spot that's hard to change. And if we go through all the work that's required to change it, it's not worth the effort. And so we just leave this mistake essentially in our code base. And so I think what a lot of us mean when we say Elm is easy to refactor is that there are a lot of mistakes that would maybe otherwise be irredeemable in other environments that are very easy to change in Elm. But if we kind of try to think more critically about what exactly are those environments in which Elm is easy to refactor, I think what we might mean is that data in particular is really easy to refactor in Elm. So I'm talking about data structures and types because we have the Elm compiler with its type checker to have our backs. Anytime we make a change to our data model, we're forced to address that change anywhere we depended on that data model. So the reason that I think this is what we mean is because whenever a sentiment I've heard before is that when we come across areas in our code that are frustrating to touch and give us that icky experience again, then a response that we have, and a good and valid response, is to push those invariants and push that trickiness into the data structure. And so I'll give you a few examples of what I mean when we talk about coding and designing this way. The first is Richard's now infamous talk, making impossible states impossible or making impossible states unrepresentable. I think it was at the first Elm Conf where he gave this talk. The remote data pattern also, I think, came out of an Elm conference talk. I'm not sure which one. But the basic idea is that whenever you're making an API request from your front end, you generally will have 4 states that that request is in. You either have not asked yet, you either are in the process of waiting for the server to respond, the server has responded maybe with something that you did not expect, or hopefully the server has ultimately responded with something that you did expect. And if you encode those 4 different scenarios into your data structure, then it becomes impossible to access data in a way that, that leaves you vulnerable to certain types of bad behavior. It forces you to address the unhappy paths, essentially. A more recent example is in a function in the JSON decode library. It's called one or more, and this is for when you have a JSON blob and there's a list in it, and you know that the list will not be empty. And so one or more is a way that you can encode with data, with types, that the list is not empty, and in fact your program cannot proceed down the happy path unless that list is actually not empty, because your program would not compile. So these are all examples of pushing invariants into data, so my question for me is, which one of these approaches would have helped me out in my 2-sentence refactor? Because I found that that was pretty tricky, and so clearly that means I need to push something into a data structure. I think that pushing things into data structures, the reason that we like to do it is because it makes it harder for people to use a function incorrectly. But oftentimes it actually does make it a little trickier to use the function correctly, because you have a little bit more ceremony in accessing information, which is oftentimes a trade-off that we're willing to make for correctness sake. But there is an ergonomic benefit, and even if we could possibly, I actually haven't thought of a way that makes a lot of sense, but even if I could have changed the types to 2-sentence to make it so that I had more of those invariants encoded in the data structures, I would have lost the ability to pass in strings to my 2-sentence function. And we use strings a lot of places in our hub-join code base. So the goal with a tool like Elm Snapshot, which I think is potentially maybe just the first step of more interesting tools to come, is to help to make the refactoring experience of behavior maybe just as easy and pleasant for us in Elm as it is with data structures. And so I think ephemeral model-based testing kind of moves us in that direction, and I'm interested to see what comes next. Maybe from me, maybe from someone else. Okay, so every mediocre magician reveals his tricks. So this is the part of the talk where I outline how Elm Snapshot works. If you look in the Elm stuff directory in the 19 subdirectory, you'll see a bunch of Elm I and Elmo files. We're going to zoom in on toSentence because that's a module I was just showing you. If we peek inside of that, you get a nice blob of text. And if you squint really closely, then you'll see that it's a condensed version of the type signature for toSentence. And so the Elm compiler uses these files to make it faster for you to do subsequent compiles over the same modules if things haven't changed externally. So it's worth saying aloud, I'm not a spokesperson for Elm, and that these files are probably considered implementation details of the compiler and the official platform. That said, there is a project called Elm mitojson that is a dependency of Elm test. So this is what Elm test uses in part to figure out all of the test types in your directory to run when you run the Elm test command line program. And so it reads those Elmi files and produces a more pleasant JSON blob. This is an example if you zoom in on one of the string types. It tells you that you're looking at a type, that the type is called string, and where in the project it's defined. And then I'm gonna change over to list now, which you'll see is largely similar, except the vars field is now filled out. And so since we had a list of strings, the whole string blob is the element in that JSON array. I didn't have space to actually put it there. So once you have that information for a module, I already showed you the trick for turning a type annotation into a fuzz test. And so that's all Elm Snapshot does. It actually was a much simpler tool than I thought it would be. And so instead of kind of having it as a downloadable, releasable project, I just wrote a blog post where I have the code in line, and you can read the blog post and copy it and paste it, and now you'll have Elm Snapshot yourself. And that blog post is also on kofi.sexy, and that's also highlighted on the top if you want a quick link to it. Okay, so ultimately, I built this project to learn, and I was playing around with this question: are there ways to improve my refactoring experience other than pushing invariants into data structures, because sometimes I'm not willing to make the ergonomic trade-off. And so I wanted to close by summarizing a conversation I had with a friend recently when he asked me how I learned Elm. And so I had the privilege of free time, and I spent a lot of that playing with code, but I tried to categorize it a little more systematically. And my categories are that first, I built something that I knew how to build. I built a lot of things, actually, that I had built before. I built tic-tac-toe. I rebuilt my wedding website years after I'd gotten married. And I rebuilt a college project. And that was great, because I could focus on figuring out the language. I'd already solved the problem in another context. I was kind of copying over the solution. But then I started building things that I didn't know how to build. And that was awesome. That was hugely helpful, because it helped me to start thinking in terms of solving the problem in the way Elm lends itself to solve the problem. So ultimately, I think this talk is about maybe encouraging you to build something that you don't know how to build, and maybe if that something is improving your refactoring experience using types, then something here might help you when you have the opportunity to tackle it. So thanks for having me again, and that is all.